If your child practices their times tables and still can't seem to use them, that's not laziness, and it's not your fault either. Repetition alone often isn't the answer. In this episode, I want to explain why and what genuinely helps instead. Welcome to Safety in Numbers, a podcast for parents of children who struggle with maths, including those with dyscalculia or a specific learning difficulty in maths. In each episode, we explore what might be happening when maths feels difficult and what parents can do to better understand and support their child. In the last episode, we considered why maths is genuinely hard for so many children. And one of the things I touched upon was the idea that when maths facts aren't automatic, everything else becomes harder too. So in this episode, I want to spend some more time on that, probably because it's the most common issue that parents tell me that they're concerned about. Now, this issue of maths facts not sticking is not due to lack of effort on the part of your child or you as their parent. Your child practices, they go over the times tables, they do the homework, they sit with them at the kitchen table on a Sunday evening, and then on Monday morning in school, it's as if none of it happened. The facts just haven't stuck. They've gone AWOL, and the child just doesn't know where to find them. This difficulty will take a whole episode to discuss because I want to explain why this happens. Once you understand why, I think things will start to make sense and you can begin to do something to address it. Now, when I talk about maths facts not being automatic, I mean that they just aren't right there when we need them. For example, if I asked you what 3 times 4 is, if you could tell me the answer is 12 without having to count up in threes 4 times or whatever your learnt strategy is, then that is automatic. This is a really important skill to have. In England, a lot of schools focus on their Year 4 pupils knowing their times tables for the national multiplication check. You may have found yourself getting caught up in this. But the purpose of learning maths facts shouldn't be for passing a test. Instead, let's think about it in terms of what knowing these facts enables a child to do. If I'm undertaking a long multiplication and I can retrieve my times tables effortlessly, then I can focus on the process of getting the answer correct by following the procedure I have been taught. It's a relatively straightforward task. Hopefully, I also understand how it gets to the answer, but that's for another episode. But if I can't recall my times tables, then there's a significant additional workload I'm adding. In the first step, I might be required to multiply 5 by 7. If I don't just know that the answer is 35, I need to stop and consider how I'm working that out. However I work it out, it's slowing me down and taking me away from what's actually being practiced in that lesson, which in this case is the long multiplication procedure. So it's most likely that I count up in fives using my fingers to keep track. But before that, I have to put my pencil down. Now I count 5, 10, 15, 20, 25, 30, 35. Okay, I have 35. My working memory is okay, so I can remember and recall 35. However, first I have to look for my pencil because it's rolled a little away from where I placed it. I find it, I pick it up. Now I have to find the question I was working on my page. Aha, got it. Now I have to work out where in the question I was up to. I finally write 35 in the correct place. Now I have to move on to multiplying the tens digit by those other digits in the top number. And I'm so focused on working out the next fact that what do I forget to do? Now, teachers across the country will be able to tell you this right now. I forget to write the 0 that means I'm multiplying by the tens digit. I carry on. I make the 2 sets of numbers and I add them together. And I get an answer. It happens to be the wrong answer, but I get one. I don't know it's the wrong answer, and I just move to the next question and I repeat. So I'm not apologizing for that forensic breakdown of what happens. In fact, I've probably missed a few more steps in there, to be honest. But what looks from the outside like a careless mistake on the paper is very often just a mind doing significantly more work than those around them. And over time, that takes a toll, not just on the maths, but on how the child starts to see themselves. So, why don't the facts stick, even with all that practice? To understand that, I need to explain a little about how memory works. Now, I promise this isn't going to turn into a neuroscience lecture. When we learn something new, it sits initially in what we call working memory. Working memory is exactly what it sounds like. It's the memory we use while we're actively doing something. It has limited capacity, so it doesn't hold things for long. So for information to become genuinely known, the kind of known where 5 times 7 just arrives without effort, it needs to move from our working memory into our long-term memory. And that transfer happens through meaning and connection, not just through repetition alone. This is where drilling runs into difficulty. Now, I want to be careful here because I'm not saying that practice has no place. It does. But there's a difference between practice that builds understanding, which is what we're aiming for, and practice that builds a performance. When a child drills times tables repeatedly, what they're often learning is a sequence, a kind of verbal chain. 7 8s are 56. It's almost like learning song lyrics. You can reproduce it if someone gives you the opening line, but ask the question a different way. What's 56 divided by 8? And that chain breaks because the underlying relationship was never really there. I've been into schools where children have scored highly on the year 4 multiplication check, really impressive scores. And then I've sat with some of those same children and asked them something simple that uses those facts in a different context, and they're lost. Not because they're not capable, but because what they've learned were the answers to the test, not the maths itself. The facts were drilled in, but they didn't have anywhere to anchor. They weren't connected to anything that gave them meaning. So if drilling isn't the answer, what is? I want to introduce an idea here that I think is worth exploring because it requires a small shift in how we think about what we're aiming for. The word that comes up a lot in maths education is fluency. And most people, when they hear fluency, think speed. I want to challenge that. Speed can be a consequence of fluency, but it isn't what fluency means. A child who understands that 6 8s are 48 and who knows that therefore 8 6s are 48 and that 48 divided by 6 is 8 and that 48 is double 24, that child has nailed fluency, even if it takes them a moment to get there. That understanding is solid. It transfers, it grows. Speed without understanding is much more unstable than it looks. Now, this doesn't mean that we don't care whether or not children are slow or fast, because in the real world, in a classroom, pace does matter, and I'm not going to pretend otherwise. But if we celebrate speed at the expense of understanding, we can end up with children who may perform well on a check in year 4 and then struggle when the same facts are needed in a different context 2 years later. The goal is understanding that lasts, and that takes a different kind of practice than drilling the same sequence over and over. I want to come back to that image of the child in the classroom who was doing their long multiplication for a moment. The one who's put their pencil down, is counting on their fingers, and has lost track of where they are. Because there's something else happening alongside the slower working and the unraveling calculations. And it's the part that keeps me, and no doubt you, up at night more than the maths itself does. That child can see the rest of the class. They can see that others are moving through the same work without stopping, without counting, without losing their place. They're not drawing a complicated conclusion from that. They're drawing the most obvious one that's available to them. And that is that everyone else can do this and I can't. And from there, it's a very short step to a much more corrosive thought that there's something wrong with them, that they're stupid, that maths isn't just for them. I meet children who have been carrying that thought for years. It started somewhere around a times table test in year 3 or 4, and by the time I see them, it has become part of how they describe themselves. Not, I find maths difficult, but I'm bad at maths. And sometimes underneath that, I'm not very clever. Now, that's a significant thing for a child to be walking around with, and it didn't come from nowhere. It came from repeated experiences of being slower, of getting things wrong, of watching others find it easy when it feels impossibly hard for them. And the wrong answers matter here too, because they compound it. A child who has worked hard, counted carefully, kept track as best they can, and still gets the answer wrong because somewhere in that detour they made an error, that child doesn't experience it as the process let me down. They experience it as I got it wrong again. The effort is invisible on that page. The result is what remains, and if that happens often enough, why would you keep trying? This is the cycle I want to highlight because breaking it starts with seeing it clearly. The difficulty with maths facts isn't just a maths problem. It affects how long everything takes, how much energy it costs, how many errors creep in, and eventually how a child understands their own ability. That's what's really going on when we talk about maths not sticking. So, what can you actually do? I want to give you something practical here, not a list of 10 things that will take over your life, but one approach that's genuinely worth the effort. If done consistently over time, it will work. The idea is simple: one fact at a time. Not the whole times table on the poster on the wall, not even one row of tables. One fact. Let's say this week it's 6/8. You choose it, or better still, your child chooses it, but either works. Before you even write anything down, ask your child to make the fact. Get some objects, coins, counters, pasta, stones, whatever you have to hand, and build an array together. 6 rows of 8, 8 rows of 6. Let your child arrange them, count them, see that 6 times 8 really equals 48. Not because someone told them so, but because they can see it and touch it right in front of them. Then, at a calm moment, so not in the middle of doing homework, not when they're tired or already frustrated, but during a quiet moment when the conditions are actually right for learning, have them write those numbers on several cards: 6, 8, 48. A few copies. And then your child decides where to put them. You can suggest places: the bathroom mirror, next to the TV, on the front door, but let them choose because ownership really matters here. They're more likely to notice a card they have placed themselves. They might even want to draw the array that they made onto their card, and if they do, encourage that because that image gives them a link back to that lived memory. Throughout the day, ask about it. And here's where I want you to think a little creatively. Don't drill it, okay? It's not a goal to recall. Instead, ask about it in different ways. Oh, what's 6 times 8? What do we get when we multiply 8 by 6? How many tentacles would 6 octopuses have? How many sides on 8 hexagons? What's 48 divided by 6? You're working towards the point where your child can just say 6, 8, 48, or 8, 6, 48, or 48, 8, 6, or 48, 6, 8. And those three numbers feel connected to them, feel automatic, feel understood. Now, what's key here is that there is just one fact. Don't rush it. This one fact may take a day, a week, or even longer to learn. But when that one fact is secure, and I mean really secure, not just today I can say it, secure, put those cards, collect them up and put them to one side and begin a new fact. Now, just because your child has shown they're secure at this point, it doesn't mean it will stick forever. I wish I could count the number of times my mum told me that I'd learnt my tables by the age of 7. Apparently, I then forgot them, and it took me a long time to learn them all again. Now, at 7, I probably didn't understand what they were. It's going back to those song lyrics. But had they been kept on the boil, I may not have had to learn them all again from scratch when I got older. And so this is crucial. Go back to that pile of cards you've set aside. There are duplicates, so have one set in the kitchen, one in their bedroom, one next to the toilet, a set in the car glove box, wherever your child spends some time. Use them like flashcards, hiding one of the numbers for your child to say the fact, or having them practice them themselves. Now, if there are any that wobble, you can put those back up. This shouldn't be seen as a punishment. If anything, perhaps you could explain that you suggested too early that they could be taken down, or that you're sorry that you'd forgotten to use the flashcards with them for a few days. It isn't a race. There's no finish line to cross before you're ready. But do be tenacious about it. Okay? That's the word I'd use. Not pressured, not frantic, but tenacious. Alongside this, I want to suggest something that might feel a bit counterintuitive at first. Get a multiplication chart, a full grid that has 1 to 12 along the top and along the side, with all the answers in the squares in the centre, and show it to your child. Not to test them, but to explore it together. Point out the duplicates. Notice that 6 times 8 and 8 times 6 are the same fact. Get your child to block out every fact that appears more than once. And what you're left with is significantly fewer facts than they thought they had to learn. I've seen that small task alone shift how the whole thing feels for a child. Then, get them to highlight the ones that they already know. As the flashcard pile is building up, revisit the chart and get them to highlight the ones they now know so that they can see visibly the progress that they're making. Now, none of this is quick. I won't pretend it is, but it's the kind of practice that actually builds the connections that move facts from working memory into long-term memory, which is exactly what we want to happen. And that's the difference between a child who passes a test in year 4 and a child who can actually use what they know. I've put together a companion guide to go alongside this episode. It's a free PDF and you'll find the link in the show notes. It takes the practical approach I've talked about today and goes into more detail so that you have something concrete to work from at home. So if the fact cards and the multiplication chart felt useful, it's worth a look. In the next episode, we're going to talk about something that's said more often than people realise, and usually without thinking, what it actually means when we describe a child as bad at maths. and why that phrase is doing more harm than we realize. If you found this episode helpful, please do share it with another parent who might need it. And if you'd like to make sure you don't miss future episodes, you can subscribe wherever you listen to podcasts or follow the Safety in Numbers YouTube channel. Until next time, thank you for listening.